Chapter 5, Number 29. Two crewmen pull a raft through a lock as shown in the figure. One crewman pulls with a force of 130 newtons at an angle of 34 degrees relative to the forward direction of the raft. The second crewman, on the opposite side of the lock, pulls at an angle of 45 degrees. With what force should the second crewman pull so that the net force of the two crewmen is in the forward direction, meaning the raft doesn't move side to side? In essence, what we're really saying is we need that their vertical components to cancel out. In other words, crewman 1 is pulling down, and crewman 2 is pulling up, as it were. But what we really care about is that crewman 2 would have a vertical part and a horizontal part, and crewman 1, of course, would have a vertical part and a horizontal part. I'm speaking in terms of our diagram. Obviously, they're really both horizontal forces. It doesn't pull it out of the river or anything. But what we care about is that the if we take sort of this as our standard axes, that the y components cancel out, so that there is no net acceleration in that direction and therefore no net motion in that direction. So we really just need to take these two vectors and figure out the y parts. So this is F2, and they tell us, well, I suppose it's fine, but they gave us a different angle, so I'm going to draw, I can pick whatever direction I want to draw to break it up. So I'm going to say, here is guy 2, and he produces a horizontal and a vertical part at some angle, which I'm going to call theta. And person 1 has a horizontal and a vertical part at some angle I'm going to call phi. And what we want to do is we want to say we need that F2y equals F1y in magnitude, so the directions would cancel. But from our diagram, F2y is just F2 sine theta. And likewise, F1y is just F1 sine phi. So we can solve this over and say that F2 would have to equal F1 sine phi all over sine theta. Or throwing the numbers that were given, we have 130 newtons times the sine of 34 degrees all over the sine of 45 degrees, which our calculator tells us is 102.8 newtons, which based on our number of sig figs, which seem to be 2, is really 100 newtons. You'll notice that Walker actually writes this as 0.1 kilonewtons, which is bizarre, and my only understanding is he does that because that way we don't have the weird trailing zero issue here of should that be 100 or 1.0 or whatever. This is still strange and no one would write it that way. If you're really, really worried, you might say it's just 1 times 10 to the 2 newtons to specify 1 sig fig. Anyway, those are all the same number really, so however you write it is fine.